Woohoo! Welcome back. Today we're going to be talking about 4.3. 4.3 is broken up into two halves. The first half is all about absolute values. And what makes this more interesting, more exciting than the previous work we've done is, as you can see down here, we're going to start taking the absolute value of variables. This is very exciting. The second part, we're going to take those absolute value, and instead of making them equations, we're going to actually work on inequalities. Woohoo! I know, this is so exciting. It's so exciting. Sharktopus is here to offer a little bit of support and to cheer you on, because I do have a disclaimer that this is possibly, believe it or not, some of the hardest math in this class. And I know there's some hard math, but this one, I think, is the section that most people have never experienced before. It's a really important section. It sets you up with some of the basics for what you will need if you go on and take calculus. It helps you understand better the relationship between positive and negatives, absolute value. It's very valuable, but it can be frustrating. So let me just remind you that you are always welcome to ask me questions. You're always welcome to get tutoring, ask the tutors questions, and I encourage you to keep asking questions until it starts to make more sense. So here, I'm going to go ahead and jump right in and do my best at explaining what the heck is going on. So I'm going to start off with some things that you hopefully already know, because we did cover this in an earlier section, and that is the basics of absolute value. So for example, the absolute value of 3 is 3. And so what I want to say about that is not just look at that equation, but then reflect and say, okay, so if I put a positive number in, 3 goes into the absolute value, I get a positive number out. Nice. Okay, what if I put a negative number in? -3 goes in. I still get a positive number out. And now this is really interesting, because as humans, if I tell you, no matter what goes in, a positive number should come out, as a human, you can be like, oh yeah, okay. But the actual math, the algebra, doesn't really understand concepts like that. When they're not positive in, positive out, algebra would expect negative in, negative out. So we've actually got a situation that would kind of confuse things. So we're going to have to deal with that down here. To make it even more interesting, we can also plug in a 0. So if 0 goes in, the absolute value of 0 is in fact 0. And I will remind you that absolute value, and this is something we talk about previously, but it may not have stuck, or it may be something that you forgot. Absolute value can be interpreted as the distance from a number to 0. So the distance here equals 3. So what's the distance from 0 to 0? It's 0. 0 is already at 0, so there's no distance at all. And some people are like, what? What's really going on? And the answer is absolute value of 0 is just 0. You can look at it as a distance. You can always also look at it from the perspective that I think a lot of people have learned, which is positive numbers, nothing happens. Negative numbers, the minus goes away. And that is one way to look at absolute value. So how does algebra look at absolute value, though? Well, here's where we get something really interesting. And this may be the first time you've seen a two-part definition. When I take the absolute value of x and I don't know what I'm plugging in, there are two rules. If it goes in positive, it comes out positive. So it comes out the same. This is unchanged. Right? 3 goes in, 3 comes out. For the second one, if a negative number goes in, it comes out positive. So what does that mean? Well, again, as a human, I can say, you just take the minus off, and you'd say, oh yeah, I understand that. But algebra doesn't understand just removing a minus. So what do we think, how do we tell the algebra what's going on? Well, the way we do that is we say, okay, we had to change the sign, right? It went in negative, it came out positive. So how do we write that down here in the general rule? Well, we say if you put x in, and if x is positive or 0, it comes out x. There's no change. This is unchanged. Okay, that's awesome. But then what is this thing? What is the minus thing? Well, this is a little tricksy. And some people have to shake their heads. You have to shake your head a lot and think about it. Maybe go lie down under a tree, think about it. Maybe go exercise, think about it. Do some music, do some art, think about it. But basically, if we want to change the sign, the best way to change the sign is to stick another minus in. Let's think about what happens. If we had a -3, if x is -3, right? What is the opposite of the opposite of x? What is the opposite of the opposite of 3? That's how we take a negative number and turn it into a positive number. If we've got that negative, all we have to do is add another minus, right? So it becomes a plus. So it's counterintuitive, but we actually stick on an extra minus to make it positive. This is the change the sign. Now, if we were in a classroom setting, I would actually say, you know what? Let's not talk about this anymore. Let me leave that there and let it just kind of sink into your head. So I would say, let's just leave it in your brain. Let your brain kind of flip it around, see what it thinks. Let's move on to some examples, and then we'll come back. Now, the problem is you can't ask me a question. Well, you can. You can totally ask this. You could stop this video and ask your monitor questions. And it is possible that I might be able to sense what those questions are. But it is a lot harder when we're not in the same room together. So definitely think about that. Write down some questions. Ask me. Let's talk about it. But for the purposes of this video, I'm going to go ahead and I'm going to say, what does this actually have to do with the work we have to do in this class? And the answer is, in fact, this definition is just something I want to introduce as a new concept, right? We've got that brace there that describes that there are 2 possibilities. So there are 2 rules attached to this. So that's a brand new concept. And I just want to leave it there and not worry about it, because in fact, the actual work we have to do in this section is easier than this would suggest. So let's talk about it. What happens if the absolute value of x equals 3? And I want to say, what is x? And I can cheat a little bit. I can go up here and go, wait a minute, we just did this. If x goes in as 3, it comes out as positive 3. If x goes in as -3, it comes out as 3. So I know that x, so from above, x could be 3 or -3. And what does that mean to us for the rest of the work we're going to be doing? Well, whenever we have absolute value equations, because of this 2-part definition, because we've got the positives and possibly 0, and the negatives, we've got 2 different possible solutions. So absolute value equations will almost always have 2 answers. Not always. Sometimes they'll have just 1. Sometimes they won't have any answers. Okay, so 2 answers, 2 solutions, 2 numbers which satisfy this equation. And if we wanted to, we could go ahead and check. So if x equals 3, absolute value of 3, does that equal 3? Yep. If x equals -3, absolute value of -3, does that equal 3? Yep. And then hopefully you're saying, but how do we know there aren't any other answers? And I'm going to say, that's where it's lucky that I have studied a bunch of math, because I give that to you as a gift. There are no other answers. And this is a situation where you kind of have to believe me. And if you were to say, wait a minute, I don't know how you could possibly know that, I would say, okay, if we look at 0, if I'm allowed to go a distance of 3 to the right, I end up at positive 3. If I go a distance of 3 to the left, I end up at negative 3. Those are our two answers right there. And you can kind of see, since you can go on a number line, you can go to the left or you can go to the right, there are two answers. So far, so good? Maybe, hopefully. Okay, so what I'm going to do is I'm going to do a bunch more problems now. And hopefully, once you see the rhythm, you'll start to say, oh, I get what we're doing. Okay, so, dun dun dun. I know, that was number 3. Don't look at number 3. Let's look at number 2. Woohoo! So, how do we set this up? So we know that once we stick 2x plus 5 inside the absolute value, and someone asked me, how do I tell absolute value? And the answer is, well, you got to try to remember to write really long lines. And I know that on this sheet, it's not easy to format in a Word document, but when you look at it online in Canvas and in WebAssign, it hopefully is more obvious. You can always ask me. So if I've got absolute value of something and that gives me 13, then I've got two options. And this is how I recommend you solve these. You don't have to, but this is the way I do it. Either 2x plus 5 was 13 to begin with, or 2x plus 5 was in the other direction, it was negative 13. This is how we're going to get two solutions. Now, the weird part about that is once you set this up, after this, the two answers are going to look really different. They won't necessarily be like positive 6 and negative 6. They will deviate a lot. So this is the last time you'll get some similarity. Okay, over here I'm going to subtract 5. So part of this looks just like all I'm doing is ignoring the absolute value, right? I just solve this as if there was no, absolute value at all. The other half is that I set it up exactly as it looks, but I've got a negative. So let's see what happens there. I'm going to subtract 5 from both sides. That's negative 18. Divide both sides by 2. And I get x equals negative 9. Now, in this case, I do recommend that you check your answers. When you solve absolute value equations, you're not going to create any extraneous answers. So if you get the answers, those are both the answers. Everything's great. So you don't have to check. But is there a chance that you made a mistake? Yes. I would always recommend with these more complicated ones, just do a quick check. So I'm going to check x equals 4. So I've got 2 times 4 plus 5, absolute value. Does that equal 13? Let's take a look. 2 times 4 is 8, plus 5 is the absolute value of 13. Is the absolute value of 13 equal to 13? You know it is. Now let's try x equals negative 9. Okay, so 2 times negative 9 plus 5. Does that equal 13 in absolute value? Well, let's see. 2 times negative 9 is negative 18 plus 5. So that is negative 18 plus 5 is negative 13. So you can see we're coming at it from both directions. Here's the positive possibility. Here's the negative possibility. That does equal 13. Life is good. So let me go ahead. I'm going to just put this up here. X equals 4. X equals negative 9. Now, I have a bad habit. My bad habit is I write the bigger number first. I don't think this is a problem, but some people would think it's improper. And because we're going to be writing out lots of double answers, it's fair for me to point out that a lot of people think they should go in order from smallest to largest. Okay, shall we try another one? Woohoo! This one's a little bit more exciting. 3 times the absolute value of x minus 2 equals 3. Now here, absolute value is really different from other things. So you've got to treat absolute value almost like its own kind of variable. How do I mean? Well, what I mean is you want to isolate the absolute value. So how do we do that? Well, in this case, if I want to get absolute value by itself, over on the left, I'm going to divide out that 3 because that's 3 times the absolute value. So I'm going to divide by 3 on both sides. So I get x minus 2 inside absolute value equals 1. Now, once I've isolated the absolute value, then I can go ahead and look for the 2 solutions. So remember, what do the 2 solutions look like? Well, one of them is going to look like x minus 2 equals 1, as if I just ignored the absolute value. And the other one is going to be x minus 2, but that is equal to, you got it, negative 1. So there are going to be 2 answers, right? The positive possibility and the negative possibility. I'm going to add 2 to the first equation and get x equals 3. I'm going to add 2 in the second equation and get x equals 1. So those are my 2 answers. Here, oh, sorry about that. Everything went sideways. Let me write out x equals 1, comma 3. Look at me remembering to do small to large. Nicely done. Gold star for me. Okay, let's go ahead and check. So, remember, do not just check this equation, go back to the original equation. So for x equals 1, I've got 3 times the absolute value of 1 minus 2. Does that equal 3? So this is complicated, but we can do it, order of operations. I've got 3 times, and I work inside, 1 minus 2 is negative 1. What's the absolute value of negative 1? It's 1, so I've got 3 times 1, and that does, in fact, equal 3. Okay, what about x equals 3? Let's give that one a try. 3 times the absolute value, let me scooch this up, of 3 minus 2, does that equal 3? So I'm going to work inside first. 3 times the absolute value of 1. Well, what's the absolute value of 1? It's 1. 3 times 1, that equals 3. Woohoo! What do you guys think? So the rhythm for absolute values is whenever you see an absolute value, first isolate the absolute value and then go for the 2 possibilities. And notice that I put the sign in front of the 1. Some people do it slightly differently. They put the sign in front of the x minus 2. I find this to be utterly confusing. But if that's the way that works for you, awesome. Rock on. Do it that way. So we've got a couple more of these, but I'm going to stop the video now because it's just under 20 minutes, which is perfect. A little math snack. Yum, 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 yum. And so I'm going to stop now. I'm going to come back, more examples, plus we'll get into inequalities. You guys are awesome. Congratulations for making it through. Remember that you're awesome. Go out and get some, get a little bit of self-care, get some rest, some exercise, some vegetables, fresh air, sunshine if you like it, darkness for me, that's my favorite. And come back and see the next video when you're ready after you've been fully hydrated. Rock on, woohoo, and math on.